Okay, let's do as an example. Let's say you want to go on a trip. You've got a certain distance you're going to cover, and you're trying to decide whether to go by car or by airplane. Let's look first at the example of the car. Now a car moves at, let's say, 100 kilometers an hour. So the distance that we're going to cover will be 100 kilometers per hour times the number of hours that we're doing. So V equals 100t. So d equals 100t. This is our equation of motion for this. That means if you travel for 1 hour, you've covered 100 kilometers. If you travel for 2 hours, you've covered 200 kilometers. If you travel for 2.5, you've covered 250. Now let's consider the case of an airplane. Well, an airplane's obviously a lot faster. Airplanes move at maybe 900 kilometers an hour, but the overhead of going and taking a flight's really high. So let's say it takes maybe 3 hours of overhead for you to fly. So you don't travel any distance for the first 3 hours, but then after that you travel at 900 kilometers an hour. So in that case we might have a different equation. V equals 900 times t minus 3. That's our equation for the airplane. Well, when would you cover the same distance with the two? What we might want to do, for example, is plot this graphically and find the solution using basic geometry with basic lines. Now, how can we do that? Let's say our vertical axis is distance and our horizontal axis is time. So our first equation over there, E equals 100. Oh, sorry, Z equals 100 feet. That's a simple straight line like that, right? Well, let's see. 1, 2, 3, so that's 3 hours. 1, 2, 3. After 3 hours, when you ride the airplane, it goes much faster. So the question is, where do these two lines come together? Where's the That's our solution for this system of equations. We have two equations and we're looking for the solution. Now how do we find that? Well, maybe you learned in basic algebra class a really simple way to do this. Here we have d on one side of the equation, and we have some terms involving t over here. Here we have d and some other terms involving t. We can just set them equal. Set the two things equal. Oh, let's see. Let's do it. V equals 100t equals 900 times t minus 3. Well, let's see. That equals 900t minus 2,700. Well, on the left over here we've got 100t, and over here we've got 900t. So if we subtract, then we have 0 equals 800t minus 2,700. So if we move the 2,700 over here, 2,700 equals 800t. So dividing 2,700 over 800 equals 2. So that equals 27 over 8. So that's the solution to our two equations here. T equals 27 over 8 is the time at which going by car or by airplane, you cover exactly the same distance as after 27 over 8, or a little over 3 hours. All right? That's nice. It works pretty well. It doesn't work very well as you add more and more variables to this. Maybe we have, instead of just D and T, maybe we also have X and Y and Z in our set of variables. It starts to get complicated. So how do we go about doing that in a more systematic fashion? That's what we're going to see with the use of matrices. Remember everyone, stay safe, and I'll see you in the next video.